Most programs need the ability to make different choices depending on an input. And with if-then-else statements, we're going to have the conditional ability to take our program in one direction or another. And this is called a control flow statement. We think of control as the decision-making processes behind where the processor is going to go next. And with conditionals and if-then-else statements, we'll see that we can test some condition, and if that condition is true, we'll go in one direction. If it's false, we'll go in another direction. So let's jump into it. So the syntax for if-then-else in Python is the if keyword. And this is a special keyword, which you can't use as a variable name or anything else. The same is true of def. So if is what we call a reserved keyword. And it's special because it starts an if-then statement. What follows the if is a Boolean expression. So here we can use some of our Boolean operators, such as greater than, is equal to, some of the complex and or and not expressions can be formed here, but we need some sort of test to follow the if statement. And I want to remind you that we're not going to write the square brackets around this. We're saying this is a placeholder, and we're denoting that this is where your Boolean expression would be written. And then there's a colon that follows the expression. And this colon is what gives Python the understanding that, okay, that's the end of our test condition. And now what comes after this on the next line, and with some indentation, is the then block. And so the then block will be evaluated if that test condition evaluates to true when it's reached. The then block can be made up of multiple lines. What's important about it is that it's one level of indentation deeper than the keyword if. And if you have multiple lines, you need to make sure that they are indented in a consistent way. An if statement can be written anywhere else. You could write any other statement in your program. So they can go within function definitions. They can go at the top level of a file. And we'll see places where we'll see reasons to use both of those things. As I mentioned, the test must be a Boolean expression. This could also be a function call where the function returns a Boolean value. So as long as whatever our expression is going to evaluate to a Boolean value, then this Boolean expression here will work out just fine. If that condition is true, we go into the then block, and that's the next place the processor will start working. It will jump into the then block and move line by line through it. If that test condition is false, it's going to jump over the then block and continue on after it. Okay? So as I mentioned, indentation is important in Python, and for an if statement, just like with our function definitions, for Python to know that the lines of code within the then block belong to it and are a part of it, we need to consistently indent the code which follows by one level. So what we're going to do next is jump into a sample, and I'm going to encourage you to follow along with this. Pause the video at this point or follow along as I work through these steps as well. And we're going to set up our first statement, if statement, and then try it out, try running it. So I'm going to jump over to Python, and I'm going to right click on lessons, make a new file for ls10, and if else.py is what we'll name this file. So ls10 underscore if else. For space purposes on my screen, I'm going to hide that, and you can still see the file name in the tab here. And I am putting this in a lessons directory. And the next thing we're going to do is set up a documentation string. So example of if then else statements, right? And so we're trying to describe what is the purpose of this file. So if you open it up and you just read the top doc string comment, you will see that have a sense of what's going on in this program. So we'll print a message to the user, guess a number. And then what we'll do is we'll set up a guess variable that will hold an integer value. And what we're going to do is we're going to ask the user for some input, right? Which is your guess, right? Now, notice that we've got a problem here. The input function is one that results in a string value, because when you type some text in to our command line and press enter, what comes back is a string. So we need to actually convert this using our int constructor to an integer. So I'm going to surround this input call with the int constructor. And so now we take that string, and assuming they gave us an integer number, we'll convert it to an integer and store the result in the guess variable. If they didn't give us something that was a number, we would have an error here, and later on we'll look at how we might handle that and behave differently with an error. But for now, let's assume that the user is giving us some data that we can work with. So now let's write our first if statement. So if guess is equal to 42. And 42 is just a random magic constant, right? So I should probably put this in a variable. Actually, why don't we do that? Why don't we practice what we encourage you to do here? And I might at the top say the answer to life, the universe, and everything, right? And this is a text reference that I would encourage you to search for. It's from the Hitchhiker's Guide to the Galaxy, right? And 42 is the answer to life, the universe, and everything, if I remember the ordering of that, right? And so I've set up a magic constant here, right? And that's kind of silly. It's a very long magic constant that really it's just the value 42, the int value 42. But what we're saying here in this conditional is if the guess variable value, which is something someone gives us when this program is running. So we have no idea of knowing what number they're guessing when we write this program, right? This will be figured out when the program is running, is equal to the answer to life, the universe, and everything, which is a named constant. And that not named constant in this program is assigned a value of 42, and we can change this in the future. Then what we're going to do is print something that tells the user they're correct, right? And notice that's one level of indentation. I'm going to make an extra line after that print statement and go back unindent by one so that we're saying this is the end of the then block. We're going to go back to our top level of indentation and now print game over, right? So now we should be able to run this program, and what we're going to expect it to do is prompt us for a guess, and then if we enter 42, we should see correct and then game over. And if we don't enter 42, then we should not see correct, we should just see game over. Right? So let's try this out. I'm going to open up a terminal here and try and keep this all in one line. And the way to do that is with the terminal menu, new terminal. There's also a shortcut that you can use with your keyboard if you want to be able to open it just by pressing some keys. And we're going to run the Python module. And the Python module is lessons dot ls10 underscore if else. So it's asking us for a number. I enter 42. And look at that. It prints correct and then game over. All right. So because my guess was assigned a value 42, when we tested whether that was equal to the answer to life, the universe, and everything, it printed correct, and then it printed game over. All right? So let's try this one more time and convince ourselves that this conditional actually works. And if we didn't guess correctly, so if I enter 41, off by 1, notice, very importantly, that this print statement did not get evaluated. We skipped over it. And the reason for that is because of this conditional that allows us to have our program decide to go in one direction or another based on some Boolean test. So we get to test something, and if it's true, we'll do one thing. If it's false, we'll do something else. All right. Now, just for example purposes, to show you that these bodies can have more than one line, we could also have a line such as print great work, which is, notice that's the second line in this then blocks set of statements. And we tried this one more time, and I entered 42. Correct, great work, game over. All right, so that works, and we see those three lines. But if we once again tried it and guessed 41, which is incorrect, notice that it just says game over. So the indentation here is especially important, just like it is with functions, and we'll see that all of our control flow statements in Python, in a function definition you can think of as not quite a control flow statement, but when you call the function, you know that you're going into that special block of statements. That function call is a change in control because we're jumping the processor out of the ordinary step-by-step sequence that it moves in. And this is a control statement, and we'll learn one more in loops later in the next lesson. All right. So let's take a look a little bit more closely at what we're seeing here. Sometimes I think it's useful to diagram using a flowchart these conditionals. And so we tend to use diamonds to represent conditionals where there's a choice and we're going to go in one direction or another. And the labels coming out of that diamond or the lines coming out of that diamond are going to be labeled with what was the test result. So if that Boolean expression evaluated to true, this is the path we're going to take. If it evaluated to false, this is the other path we're going to take. So notice that when we have an if-then statement, like we just wrote in our program, if that test evaluates to true, we do what's in the then block. But if it's false, we're just going to skip over the then block and continue on, right? both ways, we're ultimately reaching some next line of code. And in our example, that was the line game over. When the game over line was reached, that was the next thing that we needed to do. Right? We could overlay this with some code, and notice in the slides, I'm not using the magic or the named constant here. I'm just using a magic number. But the same idea applies, and we could think of this as an evaluation of that named constant. And notice that when that evaluates to true, we go into the then block, we do whatever it is, and then once we reach the end of the then block, we continue on wherever our program goes next. And if it's false, we skip right over it. Right? So what if we wanted to do something different when something was false? So what if we wanted to print incorrect if someone guessed false, not just game over? Because it's kind of it's not too nice to the user to just leave them hanging there with a game over and no, like, what was the point of this if they guessed incorrectly, right? So this is where if then else statements come in, and the else branch is going to be an extension of if then. So you'll notice that it looks exactly like an if then statement for the first two lines. And remember, we can have as many lines in the then block as we want. We just need them to be indented consistently. And then for the else block, notice it's the keyword else. So this is another special reserved word in the Python language and in most programming languages that we need to be careful not to use here. And it's followed by a that we need to be careful not to use as a variable name, but we do want to use when we're trying to write conditionals where we want one thing to happen if the test is true and something else to happen if the test is false. So it's the keyword else followed by a colon. And then once again, for the else block, we're going to indent the lines within it. And from there, we'll see that we can have multiple lines as well. Right? So we'll extend our code in just a moment. So the only difference here is that when the test is false, we're going to go into the else block instead of just jumping over the whole thing. All right. So let's try adding an else statement to our working example here. So to do so, I'm going to make my terminal a little bit smaller here. We have this if guess is equal to the answer to life, the universe, and everything else. If someone didn't guess that, we're going to print incorrect. Right? And so now this is our else block. We have the else keyword followed by a colon, and then anything that's the lines that follow, as long as they're indented consistently, they're going to belong to that else block. Right? I should note that if you wanted to have two levels of indentation, this isn't considered good style, but it's the same as one in terms of interpreting this program. Right? So you'll see in just a moment where we can actually have nested if then else, where there's going to be multiple levels of indentation. The point is there's at least one level of indentation in each of these two blocks. All right. So let's try running this. I've saved this program, and I'll just get this conditional right here. And I run my program again. My guess is 41. And notice now we're printing incorrect. Right. So we're seeing a different behavior when this test condition evaluates to false. If I try this program one more time and ran with 42, the correct number, we see what happens in the then block, but we don't see incorrect, right? So with an if then else, our code is going to jump either into the then block or into the else block, do whatever's in those, and then continue on just past it, right? So we can imagine this with a control flow diagram as well, where our test, if it's false, notice we're going to go into the else block. And this is different from what we were doing before, where we were just continuing on with whatever came after with the if then. And then if it's true, we're going to go into the then block, and we're going to skip over the else, right? So notice there's the only way to get to then is with true in your test. The only way to get to else is with false in that test. And these are two different directions, or the control of our program will move in depending on that conditional. All right. As I mentioned, we can nest if-then-else statements within other if-then-else statements. So in the then block or the else block, you can write other additional if-then statements, right? As I mentioned before, anywhere you can write a regular statement, which includes the statements in the then block, the statements in the else block, you can write an if-then-else statement. So these can compose, and you can write more complex logic here. So let's try this out. And what we're going to do is take a look at this idea that we can have blocks that have more than one statement in it, which we've already seen with both, or with our then block in our example. And then we're going to write an if then else in our else block that says, let's tell the user whether they guess too high or too low, depending on their input guess. All right. So let's try extending our program. And what we'll do is jump in. And instead of just printing incorrect, let's try and be a little bit more helpful. Let's make this a number guessing game where we tell you whether you guessed too high or too low. So notice I'm one level of indentation deep in the else here. And I'm going to say if guess is greater than the answer to life, the universe, and everything. And here's a place where, oops, this autocomplete, notice it's trying to tell me what to do. Once I see the top result, that's the thing I'm trying to type in autocomplete, if you just press enter, it will carry the rest of that out. You don't have to type it all, which is really nice. So we're making another if statement. We're saying if the guess is greater than this named constant, then in this case, what we're going to do is we're going to print too high. Else with a colon, and notice there's another level of indentation. So even though this print statement is 2 levels deep, because it belongs not only to the else block of this outermost if, it also belongs to the then block of this nested if. Similarly with else, we indent one more time, and we'll print too low, right? And the reason we know it's too low at this point is because we've already tested whether or not they're equal to one another, right? And if they're not equal, then it must either be too low or too high. And so we're going to go in that direction. So notice there's 3 possible outcomes here. Either you guess correctly, or you guess too high, or you guess too low, right? So I'm going to save my program, and I'm going to go back to my terminal. I'm going to scroll this so that this is at the top of my screen, just so you can hopefully see it. All right, so we've got it all there. And now I'm going to run this one more time. So what's my guess? Maybe I'll try 41. Notice it tells me now too low, and then game over, right? So the guess, when we entered it, the input was read during this function call. We converted it to an integer value and stored it in the integer variable guess. And then we went on to test if that guess is equal to 42, is what this named constant was in our program. Then we would print correct, but that wasn't true. Like, this was a false statement, right? I entered 41, so this would have been false. When you reach a conditional and the test is false, control will jump into the else block, right? And so what happens in the else block? Well, we reach another conditional. And in this conditional, we're saying if the guess, which was 41, is greater than 42, well, that's also false, right? 41 is less than 42. So this is a false expression given the input that we provided. So then we're going to jump into this else and print too low. And that's what led to that. And then after we reach the end of our blocks, we continue on in our program to game over. All right. So let's try this with too high to convince ourselves that that works too. So guess a number and 43. Too high, game over. Same logic applies. When we get to this test with 43, because it wasn't equal to 42, we test is 43 greater than the answer to life, the universe, and everything. That's true, right? Because 43 is greater than 42, and then we're going to print too high. Now we can try this one more time and give the correct answer. So 42, and notice it says correct, great work. And because that was the then block, and we're going to skip over the else block, we're going to jump right past those statements and go straight to print, right? So because this test condition was true, we jump over the else body, right? And so if this didn't work in this way, we would have expected too low to print again, even though they're equal to one another, right? So it's worth convincing yourself, when you guess correctly, be sure you understand why neither of these statements get printed, right? And why we are able to jump over this entire else block. And it is because this if-else statement, they're connected to one another, right? They're related to the same test. And if this test is true, we're going to do this and skip over all of this. If it's false, we're going to skip over all of this and do this, right? We can also have if-then-else statements in the then block. We could have more nested if-then statements in either of these nested statements. Anywhere you can write a statement, you can write another if-then-else statement. All right, and we'll be able to write some interesting complex logic in this way. All right, So that's a quick introduction to if then else statements. They allow us to write conditional code that will take the control of our program in one direction or another. And the way that we test whether or not we want to go in one direction or another is with a Boolean expression. So we'll see that the relational operators, less than, greater than, equal to, as well as functions that return Booleans are going to be sort of our bread and butter when working with these things. And we're going to be thinking about what are the assertions or what are the tests that we can make in order to know which step we want to take next. And only do that in certain cases. Next, we'll look at looping with while, which is related to if then else, but allows us to run a block of code many, many times over. Great work.